discuss LeetCode problem number 19, Java solution. Remove nth node from the end of the linked list. But before we discuss, please like, share, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the posts page. Please check it out. Now back to the problem. You are given a linked list like with 1, 2, 3, 4, 5 like this, and if you are given n equals to 2, we need to remove the second node from the end. So in this case, which is 4. So the difficulty comes because the linked list, you can traverse in only one direction, and you don't know where the end is. So if you have to pick the second node from the end, it is very difficult. But there is a strategy technique of slow and fast pointers which work in linked lists. I think anytime there is a linked list problem, you get stuck in an interview or something like that. Two things I think which will help, like create a dummy sentinel node first. That's one thing, and then you usually return dummy.next. And the second thing is try to see if fast and slow pointers, which we'll discuss, will that work or not. So let's finish off with this example, like 1, 2, 3, 4, 5 n equals to 2. You need to return the linked list 1, 2, 3, 5, which the node with value 4 deleted. Let us take a look at the Java solution. So this is the actual structure of the node, and so you, as I said before, like you create a dummy thing with the pointing dummy dot next is always the head node, which is given as an input parameter, and then you create the fast also points to dummy, and then slow points to dummy. And now this is the technique basically which will solve the problem, because you have to remove nth node from the end. You basically move the fast pointer n nodes, and then basically you have moved the fast and slow pointers. When the fast hits null, then we'll look at an example. When the fast hits null, the slow is pointing to the node before the node you want to delete. So that's when once you come out of this loop, you just say slow.next equals to slow.next.next. So you basically delete it. I think there is a memory leak here. If our garbage collection will pick it up. So you don't have to worry about deleting the node, especially in Java. So in C++, maybe if you're not using smart pointers, you have to delete it. And then at the end, you return dummy.next. So this is the third thing I was talking about at the beginning of the video. Like you create a dummy node pointing to the head, and then try to see if fast and slow pointers work, and then return dummy.next. Now let us take a look at this solution. This run, sample run 1, 2, 3, 4, 5. So you have to remove n equals to 2. So you fast pointer moves to 1, and then fast pointer moves to 2, and then fast pointer moves to 3. Because of, I think, it is less than or equal to n, and then you start from 0. So it is 3 pointing to 3. Now you move both fast and the slow. Slow moves to 1, fast moves to 4, and slow moves to 2, and then fast moves to 5, and then slow moves to 3, and then fast is null. That's when it comes out. So when it comes here, slow dot next, slow is pointing to 3, slow dot next is slow dot next dot next, which is basically 5. Slow dot next is pointing to node with value 4, whose next is pointing to 5. So that's what gets 4 out of the linked list. That's it. Comment below if you have any questions. Otherwise, I will see you in the next video.